Hi, welcome to the Dummy Programmer. So today we are going to solve a problem called linked list cycle 2. It is a variation of the problem we did in the last video, which was to detect whether a linked list has a cycle or not. And in this question, we are asked to return the node where the cycle begins. Okay, the starting node where the loop actually begins. And if there is no cycle, return null. Okay. If you think about it intuitively, you could just use a dictionary to store the nodes that you come across. And if you come across a node that is already present in the dictionary, that is going to be the starting node. But this is a medium level problem, okay? So this solution is probably not going to cut it because it uses space, right? I think to solve this correctly, we have to use constant space. And there is a solution for that. It's a bit mathematical. That's why I prepared a few notes for you. We'll go through this. Let's see. So before this, if you have not watched the previous video, please go and watch it because we are going to build on top of that solution. Okay. This is not going to make sense if you don't watch that. I'll link it in the description box below, but make sure to watch that first. Okay. So in this case, I hope you understood the question. Our question is basically this: if this is your linked list, return the starting node of the loop, which is 2 in this case. Okay, so we are going to just return the node 2. So how are we going to do that? Okay, so let's say you have this linked list, right? If you look at it, 8 is actually pointing to 4. The next pointer of 8 is actually 4, which is here. So you can imagine 8 looping around like this. I can't draw circles here, so I've represented it like this, right? So first, let's see where are they going to meet? How are we going to know whether a cycle exists or not? In the previous video, we used 2 pointers. We used a fast pointer and a slow pointer, and the fast pointer moved twice the speed of the slow pointer, and wherever they met, that meant if they ever met anywhere in their traversal, that means there is a loop in the linked list, right? So I have 2 pointers here. I have fast and I have slow. Fast is going to move 2 nodes at a time. Slow is going to move 1 node at a time. Okay. And if you look at this linked list, 4 is actually the starting node of the loop. So the output of traversing this should be 4. Okay. Now let's first see where they meet. Okay. So the slow pointer, when the slow pointer moves to 2, fast pointer is actually going to move to 3, right? Because fast moves 2 nodes at a time. Slow moves to 3. Then fast is going to move to 5, right? Slow moves to 4. Fast moves to 7, right? Slow moves to 5. Okay. Fast is going to move to 8. 8 is going to loop back to 4. So actually fast is going to come here. So it went to 8 and then it came to 4, right? Now slow is going to move to 6. And fast is also going to move to 6 because it moves 2 nodes at a time, right? So 6 is your meeting point for fast and slow pointer in this linked list. Okay. Now this is where the story begins. So we have to consider 3 parameters here. One is the distance between your head node and the starting node. So which is starting node is 4. We're talking about this distance 1 to 4. Okay, I have represented it with A. So this distance is basically A. Length of the loop. So loop is basically a circle, right? So how many nodes are there in that circle? That is represented by C. Okay. And then the offset of the meeting point from the starting node. So meeting point is 6 and the starting node is 4. So the distance between 4 and 6 is represented by D. Okay. So in this approach of fast and slow pointer, the fast pointer moves twice the speed of the slow pointer, right? So the distance covered by the fast pointer when compared to the slow pointer is going to be twice in the same time, right? So we say fast distance is equal to 2 times the slow distance, right? Now, what is the distance that the fast covered to get to this meeting point. How much is the distance, right? So the distance is basically A, which is head to the starting point, this, plus if it did X number of times, it went around the loop X number of times, then it is going to be X into C and plus D. D is the offset of the meeting point from the starting node. So between 4 and 6. So first it went to 1 to 4, and then it went around the loop a few times, and then from the starting node to the meeting point, right? So this is the distance covered by the fast pointer. At the same time, slow pointer also went from 1 to 4. It circled around CY times in the same time, and it also covered the distance from 4 to 6, which is your starting point to the meeting point, right? But this distance is twice of this distance, right? So this is the equation, and when you solve for it, this is what you get. What you get is A, which is this distance, plus D, which is this distance, is a multiple of C. The length of the loop. Okay, what does it tell us? It tells us that if at this point you leave the fast pointer here, and if you move slow pointer to the head node, and they both start moving one pointer at a time, their meeting point is going to be the starting node. I'll prove it to you. So if we leave, it's based on this relationship, right? A plus D, the time slow pointer is going to take to cover A plus D, the same time F is going to take to come to the starting node. Okay. In that time, it will come to the starting node. That will be the first meeting point. Okay, so I'll prove it to you. So F, if we leave F here at the meeting point and we move S to the head node, and now both pointers move one node at a time. Let's see what happens. Okay, so S moves to 2, right? And F is going to move to 7, right? S moves to 3. F is going to move to 8, right? S moves to 4. 8 is looping back to 4, right? The next point of 8 is 4. So 8 is so F is going to come here, and which is the starting point of the loop. And this is based off this relationship. So A plus T, A plus A, this is A, and this is D, is a multiple of C, which is the length of the circle. Okay. So based on this, our implementation is going to be, we'll solve it. The solution is actually pretty small, but understanding it could be a bit tricky. So let's solve it. Okay. So what if you get a head as null, or head is head dot next is because if there's only one node in the list, then there's no cycle, right? So we just return, because if there's no cycle, what is going on? Okay. If there's no cycle, then we just return null. Okay. Now you have a fast pointer which you initialize to head. You have a slow pointer which you initialize to slow. Okay. Now head is equal to head dot, not head, fast is equal to fast dot next dot next. Slow is equal to slow dot next dot next. Okay. Sorry, it's evening and I'm already exhausted. Yeah, so fast is moving 2 pointers, slow is moving 1 pointer, right? And we move this while slow is so how do we detect whether if pass is equal to nil, we did this in the last video, right? Pass is not equal to nil, because if it is equal to nil, that means there's no cycle, right? And past dot next is not equal to nil, because this will never happen. It will never reach. Reaching the end would mean the next pointer is nil, or it itself is nil, right? Pass is equal to, basically we move this forward. and we check if fast is equal to slow. That means if they have met, then we break out of this. Okay. At this point, we have to also check that if fast is not equal to slow, that means there is no, what is this operator? Okay, sorry, I think it is this operator, right? Then return null. So what we are trying to do is we are moving both of them forward until we reach, so this loop is going to execute until fast is either becomes nil, that means there is no loop, or we have fast is equal to slow, because we are going to stop at that point. We have to stop at the meeting point. And here we don't know whether fast became nil or whether this condition was met. Either this condition was met or this condition was met, and we broke out of the loop, right? So we have to verify whether we actually had both pointers meeting at some point. So this is what we're doing here. If it is not equal to slow, then we return nil. That means there is no loop. Okay, so we are at this point now, the meeting point. Both fast and slow pointers are at this location, right? Now what we are going to do is we are going to put slow back to the head. So we are going to say slow is equal to head. Okay, so why slow is not equal to fast, we are going to, because what we are saying is that if slow starts moving from the head and the fast pointer starts moving from the meeting point, the next meeting point is going to be the starting node. So we are going to increment slow dot next, and fast is equal to fast dot next, right? They are both going to move forward, and then they are going to be at the starting node, and we return slow pointer, because slow is going to, both pointers are going to be at the starting node. This is the whole solution. The solution is pretty simple, but to understand why it works is a bit tricky. Okay, so let's see. If it is a nil pointer, or if it has only one node, then we are going to return nil. Otherwise, we are going to initialize. See, my brain is at 50% capacity. So fast is equal to head and slow is also equal to head, and we increment both of them forward. Fast moves at twice the speed, slow moves one node at a time. And we run this loop until either fast reaches the end of the linked list or fast and slow meet at some given point. And we increment both of them forward. And now they are at the meeting point. If they never meet, that means there's no loop and we return nil. And if they meet, then we put slow to the head of the linked list, and fast is at the meeting point. And so when they start moving from those two locations, the first meeting point is going to be the starting node of the loop. And that is what we're going to do here. Let's run it. Yes, it passed. I think all 3 test cases passed. This was it for this video. If you have any questions, please put them in the comment section. If you like the video, please like it, share with your friends, and subscribe to the channel. See you in the next video. Bye-bye.